Objective 1.11 Wireless Principles. In this section, we leave the world of cables behind and dive into the invisible world of wireless principles. As a network administrator, you need to understand how data travels through the air just as well as how it travels through a wire. Let's break down the 4 core components of Wi-Fi technology. 1.11a Non-overlapping channels. Think of Wi-Fi channels like lanes on a highway. If 2 cars try to drive in the same spot at the same time, they crash. In wireless networking, if 2 nearby access points use the same or overlapping channels, it creates radio noise called interference, which slows everyone down. In the older 2.4 GHz band, there are only 3 clean lanes that don't overlap at all. Channels 1, 6, and 11. When setting up a network, you always want to stick to these 3. The newer 5 GHz and 6 GHz bands have many more non-overlapping channels, which is why they feel so much faster and less crowded. 1.11b SSID, the network name. SSID stands for Service Set Identifier, but you can just think of it as the network's nickname. It is the name you see on your phone when you're trying to join the Wi-Fi. In a big office, you might have 50 different access points all broadcasting the exact same SSID. This allows you to walk from one end of the building to the other without your video call dropping, because your device stays connected to the same name, even as it switches physical radios. 1.11c RF, radio frequency. RF, or radio frequency, is the actual physical wave carrying your data. There are 2 main things to remember about these waves: range and penetration. 5 GHz waves are like high-speed sports cars. They carry data very fast, but they crash into thick walls and stop. 2.4 GHz waves are more like rugged trucks. They are slower, but they can travel much further and pass through walls and obstacles with ease. 1.11d Encryption. Because wireless signals fly through the air for anyone to hear, we must scramble the data using encryption. This ensures that even if a hacker sniffs your signal out of the air, they can't read your emails or passwords without the secret key. For the CCNA, you should know the history. WEP is the old, broken standard, never use it. WPA and WPA2 were the standards for years. WPA3 is the modern king. It is the strongest and most secure version available today. Always aim for WPA3 to keep your data safe. Closing tip. To get some hands-on experience, I recommend opening Cisco Packet Tracer and adding a wireless controller and a lightweight access point. Try changing the SSID and setting the encryption to WPA3. Watching a laptop virtually connect to the signal is a great way to visualize these invisible principles. In Objective 1.12, we explore one of the most revolutionary concepts in modern IT: virtualization. In the past, if you needed 3 different servers, you had to buy 3 physical boxes. Today, we use virtualization to run multiple virtual systems on a single piece of powerful hardware. This saves money, space, and electricity. The 3 pillars of virtualization. 1. Server virtualization. Imagine you have a massive physical server with a lot of CPU and RAM. Instead of letting it sit at 10% usage, we install a special layer of software called a hypervisor. The hypervisor carves that one physical machine into several virtual machines, or VMs. Each VM thinks it is a real computer with its own operating system, like Windows or Linux. Because they are isolated, if one VM crashes, the others keep running perfectly. This is the backbone of the cloud. When you rent a server from Amazon or Google, you are usually just renting a VM on their massive hardware. 2. Containers. Containers are like the younger, faster brother of virtualization. While a virtual machine simulates an entire computer, including the bulky operating system, a container only packages the specific application and the files it needs to run. Think of a VM as a full house with its own plumbing and electricity. A container is more like an apartment in a complex. It shares the main plumbing of the host operating system but stays private and secure. Because they are so lightweight, developers can start or stop thousands of containers in seconds. You'll often hear the name Docker when talking about containers. 3. VRFs, virtual routing and forwarding. Now let's bring virtualization into the networking world with VRFs. Normally, a router has one routing table, a master list of where every IP address lives. A VRF allows you to create multiple, independent routing tables on a single physical router. This is incredibly useful for security. For example, you could have one VRF for guest Wi-Fi and another for internal finance. Even though they are using the same router, the guest network physically cannot see the finance network because they exist in different virtual routing universes. It's like having two separate routers for the price of one. Practice and visualization. Virtualization can be hard to see because it's all software. Here is how to practice. On your PC, download Oracle VirtualBox. It's free. Try to install a version of Linux inside your Windows or Mac computer. Seeing a second computer screen pop up inside your main one is the aha moment for server virtualization. In Packet Tracer, while Packet Tracer doesn't fully simulate complex VRFs, you can practice VLANs, which is the switching version of this concept. Deep dive. Search YouTube for VMs versus containers explained to see a side-by-side visual of how the software layers differ. Mastering these fundamentals is key because modern networking is no longer just about hardware. It's about how we manage virtual resources. In Objective 1.13, we look at the brain of the local network, the switch. While routers connect different networks together, switches connect devices within a network. They are much smarter than the old-fashioned hubs because they make intelligent decisions about where to send data. Switching Concepts Objective 1.13, Switching Concepts 1.13a, Mac Learning and Aging. Learning. Imagine a switch is like a building receptionist. When it first turns on, it doesn't know where anyone sits. However, every time a computer sends a message, called a frame, the switch looks at the source MAC address. It says, "Okay, I see a message coming from address A on port 1. I'll write that down." It learns the location of every device just by watching who is talking. Aging. The switch doesn't keep these notes forever. If a computer is unplugged or turned off, its entry in the table will eventually expire and be deleted. This is called aging. It ensures the switch's memory stays fresh and doesn't get cluttered with devices that are no longer there. 1.13b, Frame Switching. Once the switch knows where a device is located, it performs frame switching. If your laptop on port 1 wants to send a file to the printer on port 5, the switch looks at its internal map, sees the printer is on port 5, and sends the data only to that port. This creates a private, high-speed conversation between those two devices, allowing everyone else on the switch to talk at the same time without getting in each other's way. 1.13c, Frame Flooding. But what happens if the switch receives data for a destination it doesn't know yet? For example, if you want to send a file to a new server that hasn't spoken yet today, the switch won't drop the data. Instead, it performs frame flooding. It sends a copy of that frame out of every single port except the one it arrived on. It floods the network, hoping the right device will hear the message. As soon as that server replies, the switch immediately learns its location, going back to step A, and stops flooding. 1.13d, MAC Address Table. All of this intelligence is stored in one place, the MAC address table. You can think of this as the switch's brain or its master cheat sheet. It is a simple list in the switch's memory that maps a physical MAC address to a physical port number. As an administrator, you can view this table at any time. When you see a list of MAC addresses and ports, you are looking at the result of the learning, switching, and flooding processes all working together. Quick practice tip. The best way to see this in Packet Tracer is to connect 3 PCs to a switch. Go into the switch CLI and type show MAC address table. It will likely be empty. Ping from PC1 to PC2. Run the command again. You will now see 2 MAC addresses mapped to their ports. This confirms the switch has successfully learned the addresses and is ready for switching.